So, good evening, everybody. Today I'm going to be talking about something which is usually taken in interest by almost everyone. It is about the search for life beyond Earth. Well, to start off, I want to ask you a question. Did any one of you here ever wonder, why are people so curious? Why do we have this great desire to learn, to know new things around us every day? Well, curiosity may be the driving force behind mankind's never-ending quest for knowledge. And over the history of mankind, we have been making lots and lots of discoveries, understanding the world around us better every day, whether it be inventing the alphabet or Christopher Columbus discovering America. Curiosity revolves around us. Our desire to learn has helped us push our boundaries, to look for things that we don't normally expect to see, to discover amazing things, surprising things. And this has led to us knowing so much more about our planet and our space and our place in the universe. It has also led to us thinking about life beyond Earth, and whether or not life could exist beyond Earth or not. So far, we are able to explore the laws of physics and chemistry beyond Earth, but biology is something that we are limited to. That's because there is no hard evidence of life beyond Earth till date. So it's quite hard to speculate on what life might look like on other worlds, and whether the basic understanding of the basic understanding of how life forms on Earth is similar to that on other worlds or not. So let's make a comparison here. It is said that there are more stars than all the grains of sand in Earth's beaches, deserts, and oceans combined. Now, if you just give all those grains of sand a certain number, it's going to be huge. Well, approximately, there are around 7 quintillion grains of sand, which is 7 followed by 18 zeros. Now, that is a huge number. Imagine there being more stars than that. Well, that'll just be too many stars and too many planets for life not to exist. Life has to exist somewhere out there in space. So the question is, where should we look for life? Well, the most common thing that researchers are looking for is the presence of liquid water in a planet's surface. Water is the source of life, and everywhere we have looked on Earth, whether it be ice-covered lakes or dry deserts, if there's water, there is life. And that is what we are looking for. In fact, we are so dependent on water that we wouldn't be able to live 3 days without water. So these are a set of graphs by famous planetary scientist Dr. Sean Goldman, and I've tweaked it in a way to make it more interesting, and it will basically help us to understand what type of planets are we looking for out there. So as you go up, the size of the planets increases, and as you move towards the right, the distance from its star increases. So these are some of the planets in our solar system. So when we are looking for planets, we are usually looking for those planets that are not too far away, not too close from the sun, so they're just right distances so that they can hold liquid water. And well, if a planet is just too close to the sun, when all the liquid water would eventually evaporate and it would just become too hot for life to exist. So that's a boundary we have there. Now, a planet cannot be too far away from the sun also, because all that liquid water would eventually turn into hard ice, which would make life hard to exist again. So that is another boundary. Now, so a planet cannot be too big, again. That's because if it is, then there'll just be too many gases out there in the atmosphere. And with so many gases, it would just become too dense for liquid water to exist. And that's another boundary. And a planet cannot be too small. That's because if it is, then it would eventually lose its atmosphere, just like our very moon. And it would be not possible for liquid water to stay again. So that is another wall. Well, these 4 walls, these 4 boundaries, create a box inside, which is our happy zone, or we can say the habitable zone. And planets inside these habitable zone are basically those planets which can support life or probably have liquid water existence. And as you can see that Mars actually falls in this habitable zone. So let's have a look at our neighboring planet Mars. So Mars is a rocky planet, about half the size of Earth. It has an atmosphere and falls in the habitable zone. Well, everything all good, right? But the good thing, well, the disadvantage is that its atmosphere is about 95% carbon dioxide. And temperatures range from 20 degrees Celsius on summer, while to negative 195 degrees Celsius on winter. So you can see the difference, it's quite a lot. Well, average temperature on Earth is about 14 degrees Celsius, and in Bangkok it's like 27 degrees Celsius. So the difference is quite a lot. And with such low temperatures, it is possible that life may not be able to exist, and maybe Mars isn't the best place to look for life. But out of all the planets in our solar system, Mars seems to be the most possible one, most promising one, which is why there's so much research and discovery into exploring Mars. So this is a rover that was sent to Mars on 2003, and it landed on 2004, and and explored Mars for quite a long time and helped return a lot of data back to Earth about Martian surface and chemicals, NASA's Spirit rover. And this is another rover that was sent to Mars, NASA's Curiosity rover, which was sent to Mars in 2011, helped landed on 2012, and has been operating till now. And this was a really successful mission because it helped to discover that water did exist on Mars millions of years ago, and it could have supported microbial life. Well, recently, NASA defined water on Mars, which is a quite exciting discovery, knowing that water is the source of all life and a planet holding it just happens to be nearby. And although the quantity of water is quite less and seasonal, it's surprising that water does exist in such low temperatures. So here's an artist's conception of what Mars look like now. That's the image to the left, and what it could have looked like millions of years ago. So did anyone see the news recently? NASA's Spitzer Space Telescope revealed the first known system of 7 Earth-sized planets orbiting around a single star, which is the TRAPPIST-1. And this is like a record-breaking discovery of the most number of most number of planets discovered orbiting around a single star. And all of these planets could have liquid water, but the chances are highest between planet E, F, and G. That's because they are in the most right distances from the sun. So, well, imagine that you were actually standing in one of those planets. Now, what you would actually see is a large star in front of you. Now, this star is quite small, but I'll come back to that. And if you actually looked up to the night sky, you would see other neighboring planets. And these neighboring planets would be so close to Earth that if you were so close to that planet that if we humans actually lived there, then we would already be a multiplanetary species with our current technology. And behind that poster which says planet hop from TRAPPIST-1e, that's because the planets are so close to each other. And behind that poster is an artist's conception of what it might look like from that planet. And well, the star looks quite big, but if we take into scale, then the star is actually not quite big. Well, above you see our planet, our star sun, and below that is TRAPPIST-1 to Jupiter. So TRAPPIST-1 is just a little bit bigger than Jupiter. Well, this is about planets and some of the planets we have discovered and we are looking at. But what if we want to explore those planets in much greater precision and detail? Well, at least for Mars, let me introduce you to this man. His name is Elon Musk, the owner of SpaceX, Tesla, and SolarCity, and some other small ventures like Neuralink, Hyperloop, etc. So he really aims to send humans to Mars and make humans a multiplanetary species by setting up a self-sustaining civilization on Mars. Now, how cool is that? Well, he plans to do this by the year 2025, which is quite a lot before NASA's aim, which is at the early 2030s. So you can see the difference. But looking at his previous achievements, we can see that he might actually achieve his goal because in 7 years, he received lots of contracts from NASA to deliver cargo to the International Space Station. And that is quite interesting. So the main way he's trying to do this is by reusing his resources. What he's trying to do is actually reuse rockets that are actually sent to space. He proposed this idea of reusing rockets and recently implemented in one of his rockets called Falcon 9, which recently delivered cargo to the International Space Station and landed back successfully. Now, this has helped to reduce the cost of space travel significantly and boost our chances to reaching Mars even higher. Well, that's Elon Musk. Now, what if we want to look for life beyond our solar system, look for planets that are really far away from Earth? Well, to do that, special telescopes such as this Kepler Space Telescopes are being built. And this was a really successful mission. It has helped discover thousands of planets. And it's something which has been a really successful mission. So the basic working of this telescope is it monitors distant stars out there, and it continuously looks at those stars, waiting for a planet to pass by. And when a planet actually passes by, it is something like that. It blocks certain amount of light received by that star. And the telescope actually monitors that light, the reduction in light, and looks and basically understands how large the planet is and what's its distance from its star. So imagine that you were actually standing on one road, and one open, wide road, and your friend is 10 kilometers away, and you're trying to look at his ring, understand the texture, and etc. And that is quite tough. It looks simple in theory, but it's quite hard to understand how the reduction in light temperatures. Well, so that helps us to discover Earth-like planets. But if we want to look for planets, we want to discover Earth-like planets, right? So we need to know the gas composition, etc. And this is the James Webb Telescope, which is launching in October 2018. And it will help to discover, it will basically look at planet atmospheres and look at the gas composition and compare it to planet Earth and discover signs of life if need be. So technologies like this and those that may be developed in the future will significantly help to boost our chances of finding Earth-like planets and finding life maybe, or intelligent life. And I can say that we may discover intelligent life or life in the next couple of years, maybe in the next few hours, or maybe in next year, next 10 years, next 50 years. Well, I can say we may do that, but it's only a matter of time before we do that, and a question of when. Thank you.